In the second half of lesson 7.3, so this is 7.3b, we're still talking about adding and subtracting radicals, but we're also bringing back the idea of multiplying radicals, and specifically how do you multiply phrases that have a radical but also a normal number with it as well. So we're going to be reviewing a little bit about what you know for foiling or distributing, and we're going to talk about conjugates. So starting with page 14 in your notes, the idea of a conjugate is that for any number where you have a plus b, that the conjugate of that will be a minus b. And this takes a couple different forms. This might be that you have a plus square root of b, and then the conjugate would be a minus the square root of b. It could also take the form of imaginary numbers. If you remember those, this would be a plus bi times a minus bi. So the numbers will be the same, but the signs between are different. This is going to be something we come back to a little bit later in our lesson. Not all numbers have to match though. So for example, these are not conjugates. It's 2 plus 4 root 3 and 1 minus 5 root 3. There's no matching of the numbers here. So instead, when you see ones that don't match, you just multiply as normal. So we'll distribute the 2 to both pieces, and we'll distribute the 4 root 3 to both pieces. When we do this, we get 2 times 1, 2 times negative 5 root 3, so negative 10 root 3, 4 root 3 times 1, and then this one is probably the trickiest one here, this last one, 4 root 3 times negative 5 root 3. So let me just put a little thought bubble down here for us. Okay, just to kind of set this aside for a second. This is what we're thinking for this very last space back here. The numbers on the outside, 4 and negative 5, that'll be a negative 20. And then on the inside, we're going to have 3 times 3. And we know that 3 times 3 can come out as a perfect number, so we're really going to get negative 20 times 3 in the back. When we simplify these numbers, we have 2. Notice that all of a sudden we have like terms. Remember we talked about like radicals in our last lesson? Root 3 is the like radical. We have negative 10 plus 4, so we have negative 6 root 3's, and then negative 20 times 3 is negative 60. Combine like terms again, we get negative 58 minus 6 root 3. So this is our answer. So this should look familiar. This should look just like foiling does, because that's what we're doing. We're distributing both pieces. Now, when you see something like this, you're going to be very tempted to do this, but I do not want you to do this. Many people incorrectly do this. They will say, oh, I have a squared, so I will say square root of 2 squared minus square root of 3 squared. So I have 2 minus 3, I have negative 1. Ta-da! But that is incorrect, and I do not want you to do that. Instead, what I want you to do is to write this out twice. Square root 2 minus square root 3 times square root 2 minus square root 3, and then I want you to FOIL, or to distribute, both pieces. So square root 2 times square root 2 is your first piece. Then we have square root 2 times negative square root 3. We have negative square root 3 times square root 2, and then we have negative times a negative is a positive, square root 3 times square root 3. When we simplify this, we end up getting 2 minus square root 6 minus square root 6 plus 3. Or we get 5 minus, notice there are 2 of these, so we have minus 2 root 6's. This is not the same as negative 1. So please do not distribute the squared. That is incorrect. You must write it twice and then FOIL as usual. So now we start talking about those conjugates, those ideas we talked about in the beginning. This is the idea where you have a plus some number times a minus that same number. Here you see it right here, 3 plus root 7, 3 minus root 7. When you FOIL these, we're going to get a new pattern out. We're going to take a look at this. So 3 times 3 is 9. 3 times negative root 7 is negative 3 root 7. Root 7 times 3 is positive 3 root 7. And then plus minus will be a negative. Root 7 times root 7 is root 49. So we have 9. Notice this, like terms, we can add them together, but we have a negative 3 and a positive 3. They cancel. So we're left with the square root of 49, which is 7. 9 minus 7 is 2. Here's what I want you to notice. You started with square roots in your answer, and we had square roots in the middle of our work, but your final answer no longer had a square root. Interesting. All right, next one. Same thing, distribute your foiling. So root 5 times root 5, this will be root 25 in the front. Root 5 times negative root 2 is negative root 10. Then we have a positive root 10. Do you see it happening here already? And then negative root 4. Again, we see that we have terms that cancel in the middle. So we end up getting 5 minus 2, which is 3. You had square roots in your starting answer for sure, and now all of a sudden there's nothing there. This should look familiar because you saw the same thing happen when you did this with i's. You had a plus bi times a minus bi, and you saw that the i's canceled. Let's just remind ourselves of that. So let's take a conjugate here of, let's say, 3 plus 5i times 3 minus 5i. And remember, what did we see happen? We ended up getting 9 minus 15i plus 15i minus 25i squared. Those middle terms canceled on us. We ended up getting 9 minus 25. Remember that that I squared is the same as a negative 1. That was a substitution method we learned. So this is really 9 plus 25, which is 34. You started with i's, you ended up with no i's. You started with square roots, you ended up with no square roots. Started with square roots, no square roots. So a conjugate, we notice when we multiply conjugates, our answer no longer has square roots or i's, depending which one we started with. So no more square roots, no more i's. We end up with a single answer, a single number. And it's irrational. A single rational number. Remember that square root of 5 is an unending, non-patterned decimal, so it's not rational, and the i's are imaginary. So rational numbers is what we end up getting in our answer, which is why we talk about rationalizing the denominator. So let's talk about our pattern here really quick. If we were to FOIL this out here and distribute the a's and the root b's, we'd end up getting a squared minus a root b plus a root b minus square root of b times square root of b is just square root of b squared. The middle terms end up canceling, so we end up getting a squared minus b. Okay, that's our pattern that comes out of this. So you'll see that happen a couple times. Now, rational numbers, that's what we said we always get out. Why is that important for us? Well, it's important for us here. In math, we have set a rule, and we said, here's our rule. Not allowed to have square roots or cubed roots in the denominator. So not allowed to have radicals in the denominator. We like the denominator. Remember, denominators deal with fractions. So we like the denominator to be a rational number, something that's easy to deal with. We don't like it to be funky numbers, so having a square root 3 in the bottom, we try to avoid that. So we try to get any sort of square roots, which would include imaginaries, because remember, imaginaries are the square root of negative 1. So square roots or imaginary numbers are not allowed to be in the denominator. How do we fix this? Well, remember, we saw that with conjugates, we can go ahead and multiply this by 4 minus root 3, and because they are conjugates, because they are the same numbers, and the only difference is the plus or minus sign, we know that our answer, way down the road here at the end of the problem, will no longer have a square root in that part, and that's what we want. Rationalize the denominator means no square roots, no i's. Now, if you do something to the bottom of a fraction, we need to do the same thing to the top so that we do not change its value. We're changing what it looks like. The numbers will look different, but we're not changing what it's worth. This is like saying you have 4 quarters or that you have $1. They're worth the same amount of money, they just look different in your hand. That's what we're doing here. It's going to be the same worth of math, but it will look different in terms of its value and how it's broken up. So step 1 is to write the conjugate. Step 2 is to make sure you do the same top and bottom. So rationalize the denominator, we're going to have to FOIL twice. We're going to have to FOIL the bottom part, and then we're also going to have to FOIL the top part. So for the bottom here, we'll do the bottom in green. 4 times 4 will be 16. Then we'll have negative 4 root 3 plus 4 root 3 minus root 3 times root 3 is root 9. If you remember your pattern from what we talked about with our conjugate rule, we said it will always be this a number squared, so we should expect 16 minus whatever's under the root, which is 3. Sure enough, down here at the bottom of our fraction, we get 16, cancel, cancel, minus 3, which will end up giving us a 13 later on over here. On the top of our denominator, FOILing out, 2 times 4 is 8, negative 2 root 3, minus 4 root 3, and then positive, positive, root 9. We end up getting 8. The root 9 will be a plus 3, and here we have like terms, so we add them together. Negative 6 root 3, so we have 11 minus 6 root 3. Notice that the top, we still have a radical because the top pieces are not conjugates. Now, if it's possible, we would want to see if we could simplify. It would have to check the front, back, and bottom numbers, but there's nothing common to 11, 6, or 13, so this, ladies and gentlemen, is your final answer. The square root, just 11 minus 6 square root 3 all over 13. One more example for us here. Rationalizing the denominator. So again, take the conjugate of what's on the bottom. So 4 plus root 15. Whatever you do to the top, you must also do to the bottom. So there we go. We're going to FOIL top and bottom. So on the bottom, FOILing this out, we get 16 plus 4 root 15 minus 4 root 15 plus square root of 225. On the top, 6 times 4 is 24, plus 6 root 15, plus 4 root 15, and then plus root 225 again. So on the bottom, we have 16, cancel, cancel, plus the square root of 225 is 15. So that will end up being 31. And then on the top, we have 24 plus the square root of 225 is also 15, plus 10 root 15. Like terms here. So we end up getting 39 plus 10 root 15 all over 31. Again, nothing common to 39, 10, 31. So we'll leave the answer as is.